mid-unit assessment for Unit 3. Number 7. Refer to the graph to the right which depicts a person skateboarding in front of a motion detector. Identify the dependent and independent variables. Well, you guys should memorize by now that x is the independent and y is the dependent. X is in charge. So here's my x-axis. So my independent, my in charge is seconds. So my independent variable is time in seconds. My dependent variable is y, and so that's feet. Your x is your independent, your y is your dependent. In section B of the graph, is section B of the graph, section B, moving away or towards? Remember we said it was at. Away and towards. So B is moving away. Why? Because it's moving up and to the right. Up and to the right. Remember to pause after each one and fill out the paperwork. All right, what is the average rate of section A? We must include our units and we have to stop and think, should our answer be positive or negative? Well, let's stop and answer that question first. The average rate of section A, it's going down, so it definitely should be negative. So let's take a look at section A. We have to find the rate, so we know we're going to make a table. We know it's going to be x over y, which is seconds and feet. So we want section A. So pick 2 points perfectly lined up with the x and y. This is 0 seconds and 2 feet. This is 4 seconds have passed, and you're at 1 foot. So now let's find the rate. Remember, it's the change in y over the change in x. From 2 to 1, I went down 1. From 0 to 4, I went up 4. So the change in y was negative 1 foot. The change in x was a positive 4 seconds. Negative 1 divided by 4 gives you a negative 0.25 feet per second. I hate mechanical pencils. Which makes sense. I went down. Negative 0.25 is pretty close to 0. I know that close to 0 means flat line. That's why it's nice and slow over a flat line. Here's another way you could deal with it. Instead of making a table, you could have just looked and said, okay, I went from 2 to 1, so I went down 1, and it took me 1, 2, 3, 4 seconds. I went down 1 foot, and it took me 4 seconds. Either way works. I like the table way. All right, 7D. In which section is the skateboarder at a rate of 0 feet per second? Well, if I'm moving 0 feet per second, that means I'm not moving. If I'm not moving, my line is horizontal or flat. So take a look here. At 6 seconds, I was 3 feet away. At 7 seconds, still 3 feet away. 8 seconds, still 3 feet away. So I haven't moved at all in section C. Why? Because I have a horizontal line or a flat line. Last one for this graph. How far away from the motion detector was the skateboard 8 seconds after it started? How far away? That means I'm looking for a distance. That means my answer is going to be over here on the y-axis where the distance is. It said 8 seconds after we started. So 8 seconds after we started, I was at 3 feet away. 8 seconds, 3 feet away. So I was 3 feet away. Again, pause and make sure that you're showing me that work and proving to me that you're learning from your mistakes. Number 8. According to the graph, which skateboarder, Ayana or Blanca, has a higher rate of change? Well, let's think about it. A higher rate of change means steeper. We just have to look and see which one's steeper. Is this one more steeper? Let's see. That one goes like that. That one goes like that. So what do you think? Take a look at the way that my pencil moves. Kind of flat. Oh, Ayana's flat. So if Ayana is flat, like this, Blanca is moving steeper, and so she's moving faster. So Blanca is moving at a higher rate of change because her line is steeper. Simple as that. All right, next one, on to number 9. So let's see. We've got Clyde. So we're both skateboarding again. Clyde starts at 0, starts right next to the detector and skates away. Derek starts at the 4 feet away and skates towards, okay? Clyde's rate of change is 2 over 3 feet per second, and Derek's rate of change is negative 2 over 3 feet per second. Explain why Derek's rate of change is negative. Derek's rate of change is negative is because the graph is going down. If the graph is going down, my rate is negative. Derek is getting closer or moving towards the detector, which is why his rate is negative. Now, let's explain this. That's negative 2 feet, and it takes 3 seconds to do that. Let's double check Derek's. So I should be down 2 feet, and it should take me 3 seconds. So 1, 2, 3 seconds, I should be down 2 feet, and I am. 3 more seconds. 1, 2, 3, down 2 more. Perfect. Derek and Clyde do not start the same distance away from the motion detector, obviously. Clyde starts 0, Derek starts at 4. How far away from the motion detector are they when they are in the same place? How far away means a distance. Y is my distance here, so my answer is going to be somewhere along here. If Clyde's moving like this and Derek's moving like this, whoa, I almost spilled my coffee. So pretend Clyde's going like this, Derek's going like this. They're going to be at the same place right there. How far away were they? 2 feet. 2 feet away. 2 feet away. All right, 10. Describe Eugene's skateboard ride. Make sure to use words like away or towards, fast or slow, constant or non-constant. Make sure to tell me where he starts and where he stops. Okay, so this is what it should look like. Eugene starts 0 feet away from the motion detector. So I got where he starts. You can cross that out. He's moving away. He moves away. Take a look at the beginning. Slow or fast? Starts really slow and then ends much faster. So he moves away slowly at first, and then gradually speeds up. Now where does he stop? 8 seconds later, he stops at 4.5 feet. So 8 seconds later, he stops at 4.5 feet away. So right here at 4.5. I answered all the questions. Oh, I didn't use slow or constant or non-constant. It was a non-constant. Whoops. I used away and towards. I used fast and slow. I used constant or non-constant. Okay, so I answered all the questions. All right, next one. What is Eugene's average rate for the first 3 seconds? So I'm finding rate, and I only want to talk about these first 3 seconds. So again, I know I'm finding rate, so I know we're going to make a table. I need 2 points in order to find the rate. So here's a point, and here's a point. He started at 0, 0, 0 seconds, 0 feet away. Then 3 seconds, he was 1 foot away. So 3 seconds, he was 1 foot away. So let's go ahead and find the rate. We know y is feet. We know x is seconds. 0 to 1, we had to add 1. 0 to 3, we had to add 3. We know it's going to be y over x, or feet, over seconds. My change was a positive 1. My change in x was a positive 3. 1 divided by 3 is 0.33 repeating feet per second. I found the average rate just in the first 3 seconds. If it asks for the average rate, you take the first dot and the second dot. All right, keep going, guys. You're doing great.